Let us balance P4 plus OH minus gives PH3 plus H2PO2 minus in basic medium by ion electron or half reaction method. For that, first step is write the skeletal equation, that's the given question. Now, let us find out which element is oxidized and which element is reduced. In P4, it's in elemental form, so the oxidation state of phosphorus is 0. In pH3, hydrogen is in plus 1 oxidation state, so 3 hydrogen plus 3, so phosphorus is in minus 3 oxidation state. In H2PO2 minus, hydrogen is in plus 1 oxidation state. So 2 hydrogen, we have 2 into plus 1, that is plus 2. Phosphorus, we don't know. Oxygen is in minus 2 oxidation state. That's a common oxidation state. So 2 into minus 2 minus 4. And the sum of the oxidation state is equal to minus 1. So x minus 2 is equal to minus 1. X equal to minus 1 plus 2, that is equal to plus 1. Here we can see phosphorus is in plus 1 oxidation state. Now, phosphorus is undergoing reduction to minus 3 oxidation state. So, phosphorus is getting reduced. At the same time, phosphorus is oxidized also. So, phosphorus is undergoing oxidation and reduction simultaneously. And this type of reactions are known as disproportionation reaction. Now, the second step, we can split this redox reaction into oxidation half reaction and reduction half reaction. So, second step, split into half reactions. P4 gives PH3, that is the reduction half reaction, and P4 gives H2PO2 minus, that is the oxidation half reaction. Now, we can balance all atoms other than hydrogen and oxygen first. Here we can see in the left hand side 4 phosphorus atom. So let us put 4 before pH3 so that phosphorus is balanced. Second equation, P4 gives H2PO2 minus. Here also we need 4 for phosphorus. So let us put 4. So now phosphorus atoms are balanced. Next step, we can balance oxygen atoms. For balancing oxygen atoms, we can add required number of water molecules. So first equation, we don't have any oxygen atom, so no need to balance oxygen. But in the second equation, we have 4H2PO2 minus, that means we have 8 oxygen atom. So for 8 oxygen atom, we can add 8 water molecules in the left hand side. Now oxygen atoms are balanced. Next step, we can balance hydrogen atoms. So for balancing hydrogen atom, if the medium is acidic medium, we can directly add H plus, the required number of H plus. Here we can see, here we have 4 into 3, 12 H plus is required, but the problem is that the reaction is in basic medium. So first I will add 12 H plus. If this was in acidic medium, this was enough. But the reaction is in basic medium. So how many H plus you are adding? Same number of OH minus you have to add on both sides. So the effect of OH minus will be cancelled actually. So we balanced the hydrogen atom. At the same time, in the second equation, P4 gives 4H2PO2 minus, we have 16 hydrogen atoms in the left hand side and we have 8 hydrogen atoms in the right hand side. So we have 8 hydrogen atoms less. So let us add 8H plus. At the same time, we have to add 8 OH minus on both sides. Now, after this, we can see in which case we have H plus and OH minus together, we can combine and write that as water molecules. So instead of adding H plus and OH minus, for balancing H plus ion, you can add the required number. For example, if you need 12 H plus, you should add 12 H2O in the left hand side and 12 OH minus in the right hand side. Directly also we can do. Otherwise, how many H plus is required? The same number of OH minus you have to add on both sides. So now we can write the reduction half reaction as 12H2O plus P4 gives 4PH3 plus 12OH minus. Second equation, P4 plus 8H2O plus 8OH minus gives 4H2PO2 minus plus 8H2O. Now let us cancel 8H2O from both sides. Now we balanced hydrogen and oxygen. Next, let us balance the charges. For balancing charge in ion electron method, we have to add electrons. So balancing of charge by adding electrons. Now, so let us write the reduction half equation. P4 plus 12H2O gives 4PH3 plus 12OH minus. Here we can see the charge in the right hand side, 12 into minus 1. Coefficient is 12, 12 into minus 1. So we have minus 12 charge in the right hand side. And left hand side we don't have any charge. So for balancing charge, we can add 12 electrons in the left hand side. So P4 plus 12 H2O plus 12 electron gives 4 PH3 plus 12 OH minus. Now the charge is balanced for the reduction half equation. Similarly, for the second equation, P4 plus 8 OH minus gives 4 H2PO2 minus plus 8 H2O. Now left hand side we have 8 into minus 1, so minus 8, and 4 into minus 1 minus 4. So we can see a difference of 4, 8 negative charge in the left hand side and 4 negative charge in the right hand side. So for balancing charge, we can add 4 electrons in the right hand side. Now the charge is balanced. Now next we have to make the charges equal in both the half reactions. So for balancing, for making the number of electrons equal, reduction half reaction contains 12 electron and oxidation half reaction contains 4 electrons. So let us multiply the oxidation half equation by 3 because 3 fours are 12. Our aim is to make the electrons equal. So let us multiply and then add the equations. So next step, after making the charge equal, let us add the equation, reduction half equation and oxidation half equation. So 3P4 plus 24OH minus gives 12H2PO2 minus plus 24H2O plus 12 electron. This is the oxidation half reaction. Now finally we can add. Now next step, we can add both the equation. Add equations, that is oxidation half reaction and reduction half reaction. Let us add. So let us add the left hand side. P4 plus 12H2O plus 12 electron, that's the left hand side of reduction half equation, and left hand side of oxidation half equation 3p4 plus 24 OH minus gives. Now let us add the right hand side of the reduction and oxidation equation 4pH3 plus 12OH minus plus 12H2PO2 minus plus 24H2O plus 12 electron. Any common ion or molecule or electron we can cancel. So here 12 electron gets cancelled and we have 12 OH minus in the right hand side and 24 OH minus in the left hand side. So when we subtract 12 OH minus from this, we will get 12 OH minus in the left hand side and this 12 OH minus will be cancelled. Similarly, we have 24 water in the right hand side and 12 water in the left hand side. So we can subtract 12 water from the right hand side. So left hand side 12 water will cancel. Here we will get 12 water molecule instead of 24 water molecules. So we cancelled water molecules. And we can 1p4 and 3p4 we will get 4p4, 4p4 plus 12 OH minus gives 4pH3 plus 12H2PO2 minus plus 12H2O. This is the overall balanced redox equation. And we can see all the coefficients are divisible by 4. So divide by 4 and we can write the equation in the shortest form. P4 plus 3OH minus gives pH3 plus 3H2PO2 minus plus 3H2O. This is the balanced equation. We have done the balancing in detail, but in this particular question, for balancing oxygen and hydrogen atom in the oxidation half reaction, reduction half reaction no change, but in oxidation half reaction you can see that the number of hydrogen atom and number of oxygen atoms are same, 8H and 8O. So in this particular situation, if the reaction is in basic medium, you can directly add 8OH minus in the left hand side. Instead of adding H plus OH minus etc., we can directly add 8OH minus in the left hand side. Then you can balance the charges by adding electron, and also you can multiply the second equation by 3 and the rest as usual like the previous case that we have already done. But this will not work out in all the cases. Here the number of oxygen and hydrogen was same. That's why we could add 8OH minus in the oxidation half reaction so that you can reduce the number of steps.